A system of linear equations has a relationship where both equations have one common solution. So these equations can be put with one another. So if you're solving in a system through substitution, you can isolate the variable in one of the systems, in one of the equations, and actually substitute it in. So in this first equation, you have y already isolated, saying that y's value is 2x minus 4. So I'm literally going to take that and I'm going to plug it in to the second equation by saying, okay, so 7x minus 2, and then I'm saying y is this value. So 2 times the quantity of 2x minus 4 equals 5. You're literally taking it and substituting it in, hence the name substitution method. So then you're going to solve this equation for your variable for x. So 7x minus 4x plus 8 equals 5. Combine like terms, 3x plus 8 equals 5. Subtract 8 from both sides, so you get 3x equals negative 3, and then divide by 3, so x will equal negative 1. Take your value for x, and now you need to find the corresponding y value. So the smartest one to plug it into would be this one that already has y isolated. So y will equal 2 times negative 1 minus 4. Y equals negative 2 minus 4. So y is going to equal negative 6. So the solution to this system is going to be negative 1, negative 6. And you can plug it into both of them and it will solve to be true. Sometimes when you're solving a system, the equation will not already be isolated. A variable won't be isolated, so you need to isolate a variable. So in number 5 here, the second equation here is easier to isolate a variable. So I'm going to just isolate y by subtracting x from both sides. So this equation is going to be y equals 4 minus x. It doesn't have to be in slope-intercept because I'm not graphing. So then I'm going to take that y equals 4 minus x and plug it in for this y right here. So I'll have 4x plus 3 times 4 minus x, the quantity of 4 minus x, equals 13, and then I'll solve. So 4x plus 12 minus 3x equals 13. Combined terms, I'll have x plus 12 equals 13. Subtract 12, you'll have x equals 1. So then to find the solution to the second one, you can plug to your y, you plug it into that equation, you'll have y equals 4 minus 1. So y equals 3. So your solution to your system is 1, 3. Make sure that you always write that. The last piece we're going to look at is word problems. And when you have a word problem, all three of these are pretty much the same. You have, it talks about turkey burgers and veggie burgers, the amount of them, and then cost. So here in number 8, it has an amount and then a cost. And same in number 9, it has an amount and then a cost, because dimes are 10 cents, nickels are 5 cents, and then it's worth the 4.30. So all three of these are set up exactly the same. You need to identify what your x and y is. Well, in this problem, I'm actually going to say T is the number of turkey burgers, and then V is the number of veggie burgers. So to set this up, I know the number of turkey burgers plus the number of veggie burgers equals the 50 total burgers. And then I know that you pay $2 per turkey burger and then $1.50 per veggie burger, and you bought a total of $90. So there is your system. The second one you have, you can let C equal number of cashews. Okay, so the kilograms, I should say kilograms of cashews, and you can let B equal the kilograms of Brazil nuts. Okay, so again, we have a total of 12 kilograms being bought. So cashews plus Brazil nuts equals the 12 total kilograms. And then we also have the price per kilogram. So $8 per cashew plus $10 per pound per Brazil nuts, or per kilogram, is equal to the $102 that you spent. Okay, so there is your system for that one. And then the last one, you have 50 dimes and nickels. So again, we're going to make D equal number of dimes, and N equal number of nickels. So D plus N, so number of dimes plus number of nickels equals total number of coins. That is supposed to be a 5. So 50. And then value. So 0.1 D, 10 cents per dime, plus 5 cents per nickel, equals the $4.30. There's the system for the third one.